Greetings, students. Let's discuss practice test for Unit 6 and 7. Let's begin. Question 1, converting degrees into radians. We times by pi over 180. And as I stated before, I don't mind if you leave this in decimal form or exact form. So the exact answer here is pi over 4. And the decimal answer here is going to be, let's just do the whole thing, 45 pi divided by 180. About 0.79, 79 hundredths. I do have most of these questions as multiple choice on the test. So it does say convert, but there's going to be most likely options, to choose from. Next question. Negative 330. Same question here. I kind of mixed this up because on the test, I know, I made one of these where you convert from radians to degrees. So for it to go the other way, you times by 180 over pi. So just keep that in mind. In fact, let me just fix this one now, because I made one of them where it's convert to degrees. So if it starts off as like pi over 7 or pi over 6 times by 180 over pi, and really what you have to do is divide these two. But you can do the whole thing, pi times 180, pi divided by 6 times by 180 over pi. It's 30 degrees. Anyways, just keep that in mind. There's one of each. One where you convert to radians, one where you convert to degrees. Alright, find a reference angle, answer in radians. I don't really care if you answer in radians or if you answer in degrees. Remember, reference angles are between 0 and 360. So if you want to convert this into degrees first, that would probably be easier for you, since that's what you're familiar with. 19 pi divided by 9 times by 180 divided by pi. That's 380 degrees. So that right there tells us what I need to do. I need to take away 360 to make it so it's between 0 and 360. Reference angle, again, starts on the axes, x-axis. So I can subtract 360 until I get between 0 and 360, and then I have to put it in the first quadrant by doing, well, in quadrant 1 it's already there, but in quadrant 2 I take 180 minus the angle. So here's just what it is. In quadrant 3 I take the angle minus 180. And in quadrant 3 I take 360 minus the angle. So if this was, for example, if this was 280, I would take 360 minus 280, I'd get 80. 80 would be the reference from the x-axis, positive x. Or if this was 230, I'd take 230 minus 180, I get 50. Alright, next one, arc length. S equals r theta. Pretty simple. That's arc length. Theta's got to be in radians though. So r6. Theta's 225, but it's got to be in radians. I fully expect just a decimal answer here. So when you do this, I have to say 6 times 225 times pi over 180. 23.6. 23 and 6/10 kilometers. Alright, that's all I got there for that one. I don't have the area of sector one here. Just the arc length. Alright, cosine is adjacent hypotenuse. Notice I do have the adjacent hypotenuse both labeled here, so there's no actual work of finding the missing side on this question. 16 over 20, which can be reduced by dividing by 4 and become 4/5. Whereas this one, I want the cotangent. Well, actually, I do have both sides for the cotangent. Cotangent's adjacent hypotenuse. Remember SOHCAHTOA. SOHCAHTOA. Tangent's opposite adjacent, so cotangent's the reciprocal of that. Adjacent over opposite. H6, which is 4/3. If you do need to find the missing side, use the Pythagorean theorem. So this missing side would be 8 squared plus 6 squared, square rooted. So if I did need to find this, I'd do the square root of 8 squared plus 6 squared square root of 100. That's going to be that side right there, which is 10. And the same thing applies here. If I needed to find this missing side here, I do the square root. I'd subtract on this one. 20 squared minus 16 squared, because I'm looking for a leg, not hypotenuse. And 20 squared minus 16 squared is 144. So that would be 12. So if I asked you for the sine here, it would be 12 over 20. Or if I asked you for the cosine here, it would be 8 over 10. Alright, for the next group, find a trigonometric function. Tangent is opposite adjacent, or y over x. So this is y, this is x, so this one's a pretty easy one to set up. Square root of 17 over 8, negative. Both of them, so it becomes positive. Tangent's positive in the third quadrant, so that makes sense. Square root of 17 over 8. Now for the sine ratio, I need the hypotenuse. So I gotta have to do the Pythagorean theorem here again. Square root of 17 squared plus 8 squared equals, we call it r squared, or you can call it h squared if you want, or c squared. It's the hypotenuse here on this diagram. 17 plus 64 is equal to r squared. That there is 81. Yeah. R squared equals 81, so r is 9. So that tells me the sine, which is y over r, 8 over 9. These two groups are fundamentally the same, 5 and 6, 7 and 8. The difference is 5 and 6 has the triangle drawn, 7 and 8 do not. And the second difference is 7 and 8, there's negative options here as well. Because there's no triangle drawn, I can have negative sines, cosines, and tangents. Anyways, so fundamentally the same questions, it's just as these two can be negative, they don't have the triangle drawn for you. If you want to draw the triangle, draw the triangle. So here I've got a triangle in quadrant 3, so I'll draw it this way with an x value of negative 8. In other words, a horizontal of negative 8 and a vertical of negative 1, square root of 17. And then here I've got a triangle in quadrant 1 with a horizontal of square root of 17 and a vertical of positive 8. Anyhow. So we got 32 points on the first page. 4 points each. There's 25 total. Alright, page 2. Without a calculator, again, I don't care if you use a calculator or not, evaluate the following functions. I changed them all to degrees for you. So the cosine of 180, let's see what it says. It's negative 1. I want the cosine of 30. Oh dear. I want exact values here. As I said many, many times, I do not want decimal approximates. So I can use the unit triangle on the board to say the cosine of 30 is adjacent hypotenuse, square root of 3 over 2. I can use the calculator to check my work. The square root of 3 divided in half, 0.866. How about the sine of 45? Once again, oh dear, that's 707. But again, I can use the triangle on the board to evaluate what the sine of 45 is, 1 over root 2. Or you can put it as root 2 divided by 2. You can also use the unit circle for that. And again, you can check your work. 1 divided by square root of 2. You need to be able to give me the exact values here. These will not be multiple choice, by the way. These will be right on. These 4 questions. Last one's the sine of 270, which should end up being an exact value, negative 1. Alright, period. Period is 2 pi divided by b. That's for sine and cosine. For tangent and that's for sine and cosine, secant and cosecant. For tangent and cotangent, it's pi divided by b, but it's 2 pi here because it's sine and cosine. Left it as multiple choice here, so you can practice. 2 pi divided by 6. Well, that's this one right here, pi over 3. Amplitude's the number in front. I'm trying to trick you. Amplitude is 4. Alright, a basic trig function graph from Unit 6. Just a basic trig function, cosecant. Alright, so the amplitude is 1, meaning it goes up and down 1. The B value is also 1, meaning it has a period of 2 pi. The C and the D are both 0, meaning it has no phase or vertical shift. So this is cosecant, meaning it goes with sine. So I'm going to start in the middle of its amplitude. It's going to go up 1 and then down 1. So up 1, back to the middle, down 1, back to the middle. So here is the sine graph that goes with this cosecant. Every time it crosses the x-axis, or its midline, as we also called it, we'll make an asymptote. And the actual graph will be from those asymptotes, approaching those asymptotes from the tops of each of the curves. Here and here, here and there. Anyways, so that's Unit 6, the graphing. If you want to go back and review it, it's probably a good idea. I'll use one of the easier graphs, so one of the basic graphs. Alright. Sine, cosine, and tangent, solving for missing sides. So solving for missing sides here, again we're going to identify, here's my angle. We're going to identify the sides given. This is the opposite side from the angle. This is the hypotenuse. We're using sine here. We have opposite and hypotenuse labeled. So the sine of 31 is equal to 12 over x. So you can switch the sides here. X is equal to 12 divided by sine 31. 12 divided by sine 31. Now if you're thinking there's another way to do this, there are a bunch of different ways to do this question actually. This is about 23.3. So what we just got done doing, the lost signs, you could do the lost signs here as well. So we do have this angle 90. So we could do x divided by sine 90 is equal to 12 divided by sine 31. That's going to give me the same answer because the sine 90 is 1. So I could use the lost signs here if I wanted to. That might be more effective for some of you guys that never actually learned this type of work. It might be more effective to do it this way with the lost signs. X over the sine of 90, because that angle is 90, equals 12 over the sine of 31. Anyhow, just keep that in mind. There's multiple ways to do these questions. 16 and 17. You don't have to use this method. You can use lost signs. And I could also actually use log cosines if I wanted to too. I could do x squared. I don't have the missing side here actually. No, I can't use log cosines. Sorry, my bad. I need 2 sides for log cosines. Anyhow, question 17. You got 2 different setups here you could use as well. If I want to do it the normal way, I'd say this is opposite again, and this is hypotenuse again. Sorry, I kind of made them both the same. So I'm using sine again here. If it was adjacent to hypotenuse, you'd use cosine. If it's opposite adjacent, use tangent. So the sine of 59 is equal to 9 over x. We got the same work as last time. X equals 9 divided by sine of 59. For that question, 9 divided by sin 59. It's about 10.5. 10.5. And again, if you want to, you can say x over the sine of 90 equals 9 over the sine of 59. You can use lost signs. So you do not have to do SOHCAHTOA here. You can use lost signs as well, which I'll leave lost signs on the board for you. It's been there for a while, and I have clock cosines up there as well for you to look at. Anyhow, so there's those. So far we haven't had anything where you need to use any of the formulas except for SOHCAHTOA, lost signs, and log cosines maybe, and the unit triangles which are all on the board. Alright, next question. Finding missing angles. So these ones, I could use lost signs on these ones as well, if I want. The main issue here is I have to find the missing side if I want to use lost signs with the Pythagorean theorem. It's not meant really to be a lot of sines question. It's meant to be like a sine, cosine, or tangent regular question. So like here's the angle. This is opposite. This is adjacent. So this is going to be tangent. Tangent of the angle, theta, is equal to 11 divided by 6 6/10. So the angle is equal to the arctan of 11 over 6.6. Second tan of 11 divided by 6.6. I wanted 11 there, not 1. About 59 degrees. You can round to the nearest tenth it says here. So 59.0. And again, if I wanted to use the law of sines here, I could use the law of sines. I just have to find this missing side first. And the same thing applies here, except I have the hypotenuse on this one. So I can just use the law of sines directly for the question. Well, this is opposite hypotenuse. This is sine. Sine of theta is equal to 11 over 14. So theta is the arcsine of 11/14. Which is about 51.8. So, yeah. Again, if you want to use a lot of sines there, that would work too. Alright, find tangent of theta if the sine of theta is 5/6, negative, and the cosine is positive. So this part here tells me the quadrant. We'll get to that when we need to get to that. This side here tells me the triangle. So I'm going to draw a triangle here. I'm going to put theta in the corner. 5/6. 5/6. We're going to need to find the missing side here for both these questions. So if it's 5/6 here, we can do Pythagorean theorem. Square root of 6 squared minus 5 squared, which is equal to the square root of 36 minus 5, or 36 minus 25, sorry, which is 11. 11. So that's that side right there. So tangent should be opposite adjacent. So the tangent of theta is equal to 5 over 11 root. It says here the sine's negative and the cosine's positive. That happens in quadrant 4, where it's positive sine, or positive cosine, negative sine, where x is positive and y is negative. Remember, cosine's x, sine is y. X is positive, y is negative here. So that's in quadrant 4, meaning tangent's negative as well. So my answer, I'm going to put a negative sign in front because tangent's negative in quadrant 4. That's the final step on there. Alright, next one. If cotangent is equal to 1.15, find the tangent of theta minus pi over 2. Alright, so the tangent of pi over 2 minus theta is equal to the cotangent, but this is in the wrong order. So I need to figure out if this is going to be a positive 1.15 or a negative 1.15. Well, if I negate this inside, that brings it to the odd functions, even odd function properties. If you negate it inside, it becomes negative outside. So this will negate. Even though the tangent of pi over 2 minus theta is the same as cotangent, this is the opposite order. So I need to negate it inside, which negates it outside. Negative 1.15. That is the even odd functions. Alright, verify the H identity. We can times both sides by cosecant here. The purpose of that is going to cancel out here and here. And then these are reciprocals as well. So they're going to reduce. And it's going to say 1 over secant squared is equal to cosine squared over 1. And that's an identity, because cosine squared is the reciprocal of secant squared. And secant squared is the reciprocal of cosine squared. So that's perfect. This one is a Pythagorean identity. Cosecant squared minus 1 is equal to cotangent squared. Cosecant squared minus 1, if I bring the 1 over here, is equal to cotangent squared. So that's cotangent squared x equals 1 over tangent squared. There's done. That's a trig identity as well. Alright. Last questions. You're going to double both sides here. That's going to become 2/4. So where is the cosine of theta equal to 2/4 or 1/2? Which angles? I'm going to type this in, cosine and arc cosine of a half. Arc cosine of 1 divided by 2. 60. Where else is cosine positive? In quadrant 1 and quadrant 4. So my first angle was in quadrant 1. I need an angle from quadrant 4 to finish this question, which is going to be 300. Again, I'm doing reference angles here. I can verify that the cosine of 300 is also a half by typing it in. Yep. Cosine of 60 is a half, and so is the cosine of 300. They're both a half. Alright, dividing by 6 here, the cosine of theta here is going to be √3/2. So where is the cosine of theta equal to √3/2? We can use the unit triangle on the board, or we can do arc cosine of √3 divided by 2. This is going to give me 30. Arc cosine square root of 3 divided by 2. 30. So there's my quadrant 1 angle. My quadrant 4 angle is going to be 330 because cosine is positive in quadrant 1 and quadrant 4. Anyways, spend some time reviewing these questions. Good luck on your test, guys and girls. I hope we do well.